All right. Recapping a little bit to what we saw last session, we start using program language to do data analysis, right? So program language can be used to do several different tasks like automating day-to-day activities, creating website, create application, creating games. You can code almost everything, but they are becoming quite popular to know technical audiences exactly to do data analysis in a more powerful and flexible way, right? Of course, it's possible to do data analysis using like spreadsheets. It's possible to use data analysis to do a little bit more sophisticated tools like BI tools like Power BI, Tableau, Data Studio, and so on. But in case we reach a limit of the amount of data that you can process or the kind of that data consolidation or even graphs or analysis, probably you have to code, let's say, your own tool, not your whole tool, but create a small set of codes that you do or crunch the data that you want to analyze, right? And right now, as I said, it's probably the right moment to do so. We have quite simple programming language like Python and R that's very easy to code, somehow natural, that even avoid a bunch of inconvenience for more legacy programming language like C, Java, and so on. So simple thing like a semicolon that you have to put at the end of every instruction. In Python, so you don't have that, and some other details like formal typing, usual in Python, for instance, or R, you don't have to declare the type of a variable. If it's a number, if it's a text, if there's a decimal number, you don't have to explicitly say that. Normally, you infer from the context that you are on, right? So programming language, it's something, we have very strong programming language that's somehow easier to code than previous one, and also have the power of cloud that's allow us to process a significant amount of data. Not only that, in a very simple, I used the word ubiquitous last time, in a very transparent way for the user. We don't have to worry about installing, configuring anything. You just click a button, you have a machine up and running on the cloud and use it for your purpose, which again, in the end is to analyze data and get ahead of your decision and your main focus, right? So in order to analyze data, the main form of data that you use, it can use different forms of data, but a quite popular or simple one to use, it's a CSV file, comma separated values, which is equivalent to a spreadsheet, to a little table that can be available on your local computer. It could be published on the web, your URL. So we use it quite a lot, this one, because it's also quite convenient. And I was also saying the environment that you use it, the cloud environment that you use, there are some few options like Jupyter Notebooks and some others. Me personally, I like quite a lot Colab, which is provided by Google, integrated with their popular general account, either any Google account, like a regular Gmail account within Google Drive. You can have those. It's very easy to use. Probably everybody has something like that. And then we used Blockly as an introduction of this rationale for coding in logic for data analysis, and then use it to leverage in order to move to code, right? At some point, of course, you can do your initial analysis using only blocks. It's totally feasible. You saw, you create the blocks, create your logic, hit play, you get the result right on the screen. But depending on the case, you have to do some specific customization or tweaking something, probably have to move to coding. And we also did this transition. We click on the tab for Python code, copy the code into our Python environment, into Colab, run throughout the Python environment, and got more or less the same results. But the idea is that from there, as you feel comfortable with a more formal language, let's say coding language, instead of drag and drop blocks, you'll probably be more productive adjusting your analysis, your codes directly on the programming language, right? That's the whole idea. So we did stuff like reading data using the block read data frame. Data frame is the in-memory representation of this table data, tabular data, and we have different data visualization blocks. One simple one is called table view that shows the table on the screen. We use that one. We discussed the idea of variable, right? So variable, it's when you want to save information to be used later on, you create a variable. I always refer a variable to like a moving box in which you have a box, you save something in the box, and you have a very good label, or should have a very good label on the box. I'm not that great to create those labels. I called one for me, for instance, DF. So DF, it's the short for data frame. And then other blocks like within the table, if you want to focus, if you want to select a specific column or a specific set of columns, you can use the block select. We can also not only filter or focus on columns, we can filter rows. So there is also a block for filter rows. Then we start doing our niche analysis. So in case we have a very large data set, with our data set that we used, it was quite short, like dozen rows, could be 12,000, 12 millions, 12 billions. The code, the logic could be exactly the same. Instead of looking for every single row of that data, if you want to aggregate, consolidate the data, probably operation of aggregation, if you're familiar with like Excel, for instance, it's equivalent to a pivot table. You aggregate, you group by a categorical column, like course. So we have a course for business administration, law, economics, and some others. And then I can apply a mathematical function, for instance, mean, on a numerical column, on this case here, grade. So what I'd get, instead of hundreds of rows, I would only get very few rows with the average grade for each one of those courses, right? And then not on aggregation, we press a little bit of three classical graphs. The first one is a bar chart. Bar chart is very useful for comparing values, right? So in case you want to compare the average of each one of those courses, a bar chart would be perfect. If in case you want to analyze proportion, not only comparing, but if you have the idea of a whole of the 100%, and if you want to analyze the proportion of those slices, we have the pie chart, and we strongly recommend that you use pie chart with actual percentage next to the labels. And lastly, if you want to analyze trend, the ideal graph would be a line plot, right? So on the line plot, on trend analysis, on the x-axis, keep in mind that we always have a time series, right? Either like a day, a year, a sequence of days, sequence of years, week, quarters, whatever it is, but it has the idea of a timeline, a time series, right? And for today, the name may scare you a little bit, but actually what I want to show today, it's additional, a couple of other summarizations, a couple of another graphs that are summarization graphs very used by statisticians. And statisticians, they are great in doing the data analysis, but they are terrible on naming things. And for starters, a lot of the things that they name probably scare people. But once you understand what the concept is and you want to apply, it's simple enough. So that's the main idea for today, right? So in a nutshell, what's the idea about statistics? So statistics, they have two main fields. We have descriptive statistics and inferential statistics, right? Descriptive statistics is very related to what just discussed last session, right? It's about understand a large population, and population here is not exactly only restricted to human population of places, but can be related to any set of records of, let's say, a sensor or any kind of information. Different records can be perceived as, or a set of records can be perceived of population. Population in this context here, again, is not limited to people that live within a specific area. So they're all about understand for large information of those records of those populations, summarize them in condensed information that can help us draw insights, right? So what actually they do, in some cases, it's hard to work with the whole population, with the whole large set of records. Let's say in the case here, it's actually a population of people. You're analyzing US voters. And let's assume within 300 million something inhabitants of the US, I'm not sure if the exact figure is, but let's say 150 million people votes in US. Even within that data set is too large. It's probably going to be very hard to do weekly election polls for 150 million people. So what statisticians can do is to select a subset, select a sample, and the sample should be carefully selected to make sure that you don't introduce bias. For instance, we cannot interview, and for 150 million, probably less than 10,000 interviews would be a good sample size to have an idea of the general population. But we shouldn't interview, for instance, these 10,000 that you sample only within Miami, for instance. Miami is very nice, but definitely doesn't represent the whole US. So the sample process, it's something that they do very carefully to make sure that have representations of different parts of the population. But anyhow, they select this subset of the whole set, right? Instead of analyzing 150 million people, they analyze on, let's say, they interview only 10,000 people. And from these 10,000 people, similar from last session, they won't keep looking for every single row of it. Even within the 10,000, they somehow would summarize, right? To have a whole spreadsheet, a whole data set with, oh, I interview Luis, I interview Maria, I interview whoever, and say, Luis intended to vote on this candidate, Maria is intended to vote on that candidate, and so on. What probably they want to summarize, it's the number of people that said that they had the intention to vote on candidate A, candidate B, candidate C, and so on. And once you have this summarization, exactly as we did, and throw that into a bar chart, it's what statisticians call histogram. That's another sample of histogram here. This is not for election pool, but for instance, for cholesterol. So X number of people, they had their cholesterol measured, and within the quantity of people that were measured, they had about 18 people that had cholesterol between 197 and 200, and about 20 people or 19 people actually between 200 and 22, and then keep going, right? So they had 4 people that had cholesterol between 207 and 210, and so on. And you had this distribution here. You see a concentration, the highest number of people with the usual, the average, the median cholesterol values, which should be something around, I don't know, 197, 202, 203 probably. But of course, we have people that has lower cholesterol, lower than 190, and have people with high cholesterol over 210, right? So that's pretty much what is about descriptive statistics. You get a very large data set, you select a very good sample. On the sample itself, we do exactly as we did last session. We summarize, throw some graphs. A statistician has a bad practice of creating fancy name for their graph. So a bar chart of a summarization, which is a counting of the number of people, let's say. Even the count itself, they call it frequency. So they use this fancy name. So what's the frequency of that sample? So the frequency, it's only the aggregation, it's only a counting. And if you throw a bar chart on the top of this counting, they call it histogram. That's pretty much it. And another very interesting that statistics do is they try to extrapolate the values that they had on the sample to the whole population. So on that part, it's they use probability, right? And that's the work of inferential statistics. So let's go back to the election pool sample. So they saw that candidate A had the 20% of intentions of votes. Candidate B had 30% of intentions of vote. Does those percentages also apply to the whole population? They don't know, but they can estimate. They can, within a confidence level and confidence interval, so let's say 20% of intentions of vote for candidate A, they can measure that out between 18% up to 22% is the intention of votes for the whole population within a confidence level of 95%. So there is still a 5% chance that the whole pool, it's completely wrong from the reality once you actually count the votes. But anyhow, it's a very good sense of the expected real value, right? So it's very useful way of trying to, let's say, even predict the future. right? AI and machine learning somehow use more or less same principles and quite the same techniques, right? Moving forward in a more practical manner, what I'm trying to show today is then some summarization techniques and a couple of new graphs that statisticians use quite a lot. I want to try to refer their names, but at the same time, I want to make sure that don't get scared by fancy names like histogram, box plots, frequency calculation, so on, quartiles, all these things, regardless of their fancy name, let's call it, they are very useful and quite easy to use and to understand, right? So let's start exactly with frequency and histogram, right? So I can use again Excel in case you feel comfortable with Excel. Let's use this very same same spreadsheet, the same TSV that's published on the web that we used last session, the record with the student grades, right? Here it is. Let me open it. I save it locally. I'm gonna open it in Excel.
Can you share the link in the chat again to the data?
Oh, sure. Thank you.
Thank you.
All right. So here is my Excel, and the so-called frequency, it's only something as simple as count the students according to either the score or their grade, right? We can calculate on the score as being a categorical value, and of course the score and the grade, they are intrinsically tied to each other, right? So a student that got above 9, between 9 and 10, they got a score A. A student that got a grade between 7 and 9, it's a B. Between 5 and 7, it's a D, and below 5, between 0 and 5, it's an F, right? So it's directly tied, but anyhow, score, it's a categorical value, and grade, it's a numerical value. It's possible to calculate frequency on both, but let's start with a categorical value, with score. It's even easier. So if you're familiar with Excel, there are several ways to do so. We could use pivot table as used last time, but let's try something different. So as I was saying, between 0 and 5, it's an F. Between 5 and 7, it's D. Between 7 and 9, it's a B. In between 9 and 10, it's an A, right? In the calculation itself, it's quite simple. There's, again, even Excel, there's several issues. So I can use the function here, count if. I can count with if within this range, and I should fix those rows. Oh shoot, I can fix those rows, and it asked me for the criteria. The criteria should be for me here the letter F, something like this, right? So there is 2 Fs here. I could do it even more intelligently. Instead of actually typing the letter F, I can rub it here. So I can drag and drop this formula and would work for the whole table. So here it is. So that's the frequency calculation, right? So I have 2 students that got F, other 2 students that got the D, 7 students that got that B, and 1 student that got A. That's a frequency calculation for a categorical value. And if you want to see the histogram is simple enough. It's only the bar chart of those values. So within Excel, I could do something like this. And from this graph, we start seeing some trend, right? So some patterns. We see there is somehow a higher concentration of higher grades, right? If you consider B as already a higher grade, you see a concentration. Of course, you have students with lower grades, with Fs and Ds, but in general, we see a concentration. We say that the histogram is skewed to the right, right? We have a concentration of higher grades, right? That's the idea. We could do something similar to numerical columns. For numerical columns, we could have something like this in Excel. I select this, and I'm gonna use a function called frequency. And for frequency, it asked me the values, the data array, the array of data, so that are the grades, and what they call the bins. Bins are buckets. So what are the limits that I want to define for us? A subset of that. I could consider even these as buckets, right? So anything up to 5, up to 10, up to 9, up to 5, up to 7, up to 9, up to 10 are then my limits. So every group of grades that fall on those buckets you'd be referred to calculation. Here it is. Oh, sorry, it should be the other end here. Should be here from 0 to 5, from 0 to 5 to 7 to 9, and until 10. Until 10, it can, oh, funny enough. There's something a little odd on his calculation, but that's the idea. Let me try one last time. Or maybe the score is not matching. Yeah, let me try one last time. Oh, yeah. I don't know exactly what's the difference, but anyhow, you got exactly the same result. So we separated the bins, the buckets, right? Scores up to 5, up to 7, up to 9, up to 10, which exactly are the scores for FDBA, right? And even repeat that here. And again, the histogram, it's simply a bar chart of it, right? So let's try that on Blockly, right? So in case, I only use Excel in case you're familiar with Excel and that somehow helps you. Let me go back to Blockly. Let me throw again the link from Blockly here. And, oh, sorry, I didn't. There. Oh, thank you, Molly. Yeah. Awesome, awesome. And again, we can start pretty much the same way. Data analysis, read data frame block. From text, I'm gonna go get this code to inform the path of our file. Which is this one. If you wanna remember that guy, within data visualization, we have table view, right? I hit play and see my table, exactly the same. And what I wanna do first, is to calculate frequency, right? So I'm gonna select a particular, and to be more organized, again, I'm gonna use variables, right? So let me create a new variable. Let me call it data. As I said, I'm terrible of naming things, but I have here my data set into a variable called data. And within my data frame, within my data, I want to select the column for score, right? So I have the select block. I can drag the variable data here into that data frame. And I want to select also, yeah, I want to select the score, right? Nothing different that we did from last session, right? So once I have only the column score selected, which are the categorical grades, right? So that letters like A, B, D, and so on. I want to calculate the frequency, exactly as I did in Excel, right? Within the menu statistics, I had a new block that we didn't saw last session, which is frequency, that I can then ask him to connect. It has the input of bins in case I was using a numerical column, and for bins I could use a list of values here, right? For categorical column I don't need it, right? But instead of if I were using grade again, if you remember here, grade is a numerical and score it's categorical, right? So if you're using the numerical column, if I wanted to define the bins, define the limits, right, as I use it here on the frequency function on Excel, I could use these bins here, and I could throw the numbers that would be my limits for the grade, right? So something between 0 and 5 would be a bin for me. Something between 5 and 7 would be another bin. Something between 7 and 9 would be another bin, and something between 9 and 10 it'd be another bin. So as it is, let me give it a try. As we have grade here, again, grade is numerical. We defined the bins. Yeah. So yeah, we had exactly the same results. Between 0 and 5, we have 2 students. Between 5 and 7, 2 students. Between 7 and 9, 7 students. Between 9 and 10, 1 student, right? Yeah, so for numerical values, we should or could use these input information of bins. Let me throw that away and go back to our simple example, which is going to be we're using a categorical column, the score, right? So for score, we don't need bins. You would simply count for each category. So score A, score B, score D, how many students we have on each. So here it is, more or less information, right? So because again, grade and score are tightly to each other, tied to each other. So we have 1 student A, 7 students B, 2 D, and 2 F, right? That's pretty much it. And again, we can keep switching between code and blocks, right? So let me grab it here. Let me go back to Google Drive. Within Google Drive, I'm gonna create a new, under more menu, I'm gonna create a Google Colaboratory. Let me throw a better name for this, day 2, paste my code. Again, he's doing simple things like importing the pandas library as short for PD. And then within PD, I can call the function reads SV, passing as parameter, as information, the path of our file. And then the result, I'm saving a variable called data. And within data, I'm selecting the column score and simply using the function value count. So that's gonna calculate the frequency, that's gonna count values. Let me hit play. It takes a couple seconds to create a new cloud machine, right? Let me take this moment to throw a better name for a notebook for last session. So we have the very same results, right? 1 student A, 7 Bs, 2 Ds, and 2 Fs. All right. Yeah. All right. So far, so good. So that's again what statisticians call frequency calculation. It's again, it's something as simple as a summarization that do accounting on a variable, very similar to what we did last session, right? Which make a lot of sense, right? To have many different records, we're gonna see how many individuals were within X range of grades, or how many individuals were within some limits of cholesterol, how many individuals intended to vote on whatever candidate. So you're gonna won't be keeping looking for thousands of records, even that thousands is a sample of even a larger population of millions. We probably have to summarize those, right? So that's frequency calculation. And the visual graph for a frequency calculation, it's a simple bar chart, but anyhow, statisticians call that a histogram. Let's try one of those. So we have here histogram. Oh, I shouldn't throw away my bins. I can do again if it's the case, but yeah, here it is. So now with the histogram, I want to use not the categorical column of score, but the numerical column of grade, and then I can throw my bins here. I'm not sure if you're gonna process it correctly, but let's give it a try. And yeah, so we don't need a table view anymore. The histogram is sufficient to us. I can, again, keep switching to Python. Am I missing anything here? Oh, what? Funny, can double check on that. Oh, maybe is this thing that's, yeah, that thing was getting in the way. Yeah, so on the Python code, it's using, again, Seaborn that you mentioned. Seaborn is another Python library, very useful for, let's say, sophisticated graphs, but we are doing pretty much the same, right? Reading the same data set, and within the library Seaborn, SNS for short, I'm calling the hisplot, histogram, hisplot, right? Plot a histogram. And then as a parameter, I'm passing the numerical column grade for our data set data. We are defining the limits for the bins for those buckets, right? And it's automatically turning off a distribution curve. In case we had this as true, instead of work with absolute numbers, we'd work with percentage. I can show that in a second. So here I have one person that got grade between 9 and 10. It's an A, right? And here you see the count of people as being absolute number. I have like 7 students, 1 student. In case I had this turned on as true, they would work with density line. They would work with percentage. So you'd count as like, instead of saying 7, would be 7 over 12 students. What's that percentage, right? So our case, absolute numbers are perfect. So the histogram, as we saw exactly, if you remember the graph back in Excel, exactly the same, right? We see 1 student with grade between 9 and 10, an A, 7 students with grade between 7 and 9, a B, a couple of students with grades between 5 and 7, which is a D, and a couple of the students with a grade between 0 and 5, which is an F. And similar to what we saw in Excel, we see a concentration of a high grade. As we say, our histogram is skewed to the right, so there is a concentration of values to the right. That's a very nice graph to analyze this kind of trend, right? Even having access with data, I could have the perception of something like, what's the histogram of the wealth distribution in Brazil, for instance? It would probably be quite different from US. It is. So for instance, the concentration of wealth distribution, let's say the median salary in Brazil, for instance, like 50% of the people live with a salary, I don't know, let me guess, $300 a month or something like that, right? Do we have people living with less than that? Yes, we have people living less than that, less than that, less than that. And have people living with more than that? Yeah, we have bunch of bankers and politicians, soccer players, and so on. Have very little, have like Neymar. I don't know if you know who Neymar is, a famous soccer player. I don't know what his monthly revenue, but let's say that's, I don't know, $10 million. I have no idea. But anyhow, I can immediately have the perception of the oddly distribution of wealth, right? There is a larger concentration when you look at the histogram. It's highly skewed to the left, right? There is a huge concentration of income, of revenue for lower values, differently from the other scenario that we are looking here, right? The scenario looking here, we have a higher concentration of grades on the high end, right? Which I assume that's a good thing for this group of students, right? So that's how we use this kind of analysis, this frequency and the histograms, right? Last couple of graphs and analysis that I want to show you guys. It's something that a statistician calls quartiles and box plots. And again, the names are a little bit frightening, at least for me. Initially, it was. But again, I have the grades separate here, a new tab in Excel, back to Excel. Let me put those in order. And again, I have a very limited data set here, only 12 students, could be 12,000, could be 12 million, would be the same rationale. But anyhow, I want to divide those 12 students in 4 different groups, right? So the group with lower grades, so divide 12 into 4 groups, going to be groups of 3, right? So the students with lower grades are these 3 ones. Let me paint them in red, that are students with risk of not of failing on the course. And then I have the 3 next ones. Let me paint those guys on yellow. And you got here up to the half of the class, right? And keep in mind that the average, let me calculate the average here. The average, or the mean, right, of grades, which again, you have to add up all these grades and divide by 12, that's the average, right? The average of grade is 7.1. But you see, if you get a 7.2, you are above the average of your class, but you're still the bottom half of grades, right? There is a grade between 7.2 and 7.8 that divides this group into a half. That's what you call a median, right? Median. So if you got something below 7.5, or the lower half of grades of your class, and only in case you get above 7.5 on the higher grade, high half of grades of your class, right? So if you got something like 7.4, even 7.4 being a little bit over the average of class, we're still in the, let's say, worst half of our class, right, in terms of grades. So that's the difference between a median and an average, right? And you keep going, selecting the next quarter. That's the idea of quarter. We divide in 4 parts. I can paint those guys in blue. And the top quarter, the top 25% of the grades, we can paint them in green. This is the top quartile, or the 3rd quartile. So 8.6 is the grade that divides people that are on the top 25% of its class, right? Here in Excel, there is a function quartile that I select the data, and another parenthesis that I mentioned the quartiles. This is the 3rd quartile. So 8.6 is the grade that decides if you're in the top 25% or not, right? And similar, we have the 1st quartile that decides if you're on the bottom 25% or not. So that's the 1st quartile. In case you get below 5.28, you are in the worst 25% of grades of your class. So quartiles, again, themes are very sophisticated numbers, named sophisticated concept, but it's not. It's only ordering your data set, cut them in 4 parts, and analyze in which part each individual is, and what are the cutting values for entering each one of those quarters. That's the quartile rationale, which make a lot of sense, right? We do this quite a lot, like for sports. If your team are become classified for next phase or not, you have these values of cutoff, right? In the graph to visualize that, again, the name is very sophisticated, but the graph itself, it's quite simple. Let me start here. The name of the graph here within Excel, it's under insert, and then there is this blue one which represents a histogram. It's a statistical. Let me open up. It has histogram that we're talking, and the other one, it's called box plot. So again, the name of the graph, it's quite odd, but it's quite simple to analyze it, right? So the lower whisker here, it shows the minimal value. So the minimal value is 3.6, right? So it shows here 3.6. The bottom part of the box is the 1st quartile, so 5.8. We have 5.8 here. The X marks the average, 7.1. The middle line on the box is the median, 7.5. The top part of the box is the third quartile, 8.6, and the upper whiskers is the maximum, 9.7. So very tightly associated with the histogram. If you had the histogram something like this, the box plot would follow very similar. Would have the whiskers for the minimal value, would have the bottom of the box to define the 25%. We're talking about the 50%, right? But to have the 25%, I'm not sure what is the income for the poorest 25% of people in Brazil. Let's say, I don't know, that's $150 per month. So that would be our first quartile. Then we would have the medium, and then would have the third quartile, right? In order to enter the 25% or 75% of the richest people in Brazil. Not so sure what the value, but let's say that, I don't know, it shouldn't be that much. Let's say $3,000 per month. Yeah, and then of course we have the other whisker associated with the richest person. I don't know if it's Neymar or not a soccer player or a politician or a banker, but we have somebody over there. So both box plot and histogram, they are tied related to each other, right? When you see concentrations on the histograms, skewiness on the box plot, we're gonna be the part of the box narrow, right? So you see a high concentration of grades in the higher grades. You see that part of the top part of the box, it's narrow in comparison to the bottom part, right? That's a symptom of concentration of values, right? So let's do that on our blocks. Again, we can use the numerical grade. I can throw away my beans again. I can go back to the statistic menu. I can use this quartile block, and I can connect it with a table view. Here we have it. Oh, here it is. Yeah, exactly the same information that we had. Oh, I was trying to show both screens, but I guess I couldn't exactly make it. But yeah, we have the same information, right? The minimal 3.6, first quartile 5.8, the median 7.5, the third quartile 8.6, and the maximum 9.7, right? And again, we can keep switching between blocks and Python. Let's grab this code. Actually, I only need this last line because import pandas already imported. I load the data frame already did. So let's skip only for the last line that matter, which is basically within our data frame data, select the column grade. And that is a very simple functional method called describe. Describe show even more details. It shows, oh, I have 12 records. The average, the mean is 7.1. The standard deviation is 1.9. The minimal value, as we saw, 3.6. First quartile, 25%, 5.8. The median, 7.5. The third quartile, 8.6, and the max, 9.7. Right? It's yeah, simple enough. And lastly, let's try a box plot. Box plot is quite simple. Let me reuse this part. You can throw away the table view and the quartile block. And within data visualization, that is box plot. That's pretty much it, right? And I can even drag the mouse around here. I can see exactly the same information. Minimal value 3.6, first quartile 5.7, median 5.5, third quartile 8.6, max value 9.7. And I can keep switching between blocks and Python. And again, everything above I already did, right? I already imported pandas, I already imported Seaborn, I already load my data frame. I only need SNS box plot, right? Very similar to like, as I had SNS hisplot, now I have SNS box plot. And yeah, it's as simple as box plot of my column grade from my data frame data. See, as much as you try, as much as you practice, you're gonna feel more literate, more fluent on coding language as Python, right? It's much shorter and easier probably to work on something like that. I'm gonna show something that, for instance, I cannot do on Blockly, but I can do here in Python. So here it is, right? I have the same information that we're discussing. But for instance, if I want to drill down that graph, I cannot, for instance, do that in Blockly, but I could do this here. Another way to code this would be a little bit different. I could say, for instance, that my in data was a terrible name. Let me call it back to df. I'm gonna call it back to df. So here on Boxplot, I could say, and yeah, let me call it back df, right? I have df working. I could code it a little different. I could have a parameter for data, and I could say that my data for this Boxplot is the data frame. On the x-axis, I wanna the column grade, right? It's another way to code the very same information. I have the very same information. It's only change the stance, change did a little rotation. But why I did that? Because besides the X value with the grade, I could throw a categorical column and break down my graph. I could have on the y-axis, I could have, for instance, the course. And now I have different box plot for each one of the course. So I have a box plot for business administration. I have a box plot for law. I have a box plot for economics. And I don't know if you remember from our last session, we had the information of, yeah, that business administration have the lower grades, law had on average lower grade than economics. But once you drill down that information, we can start having different business insights, right? You can see here now that, okay, on average, law has lower grade than economics. Economics is a very good course or very homogeneous type of group because they don't deviate too much. All of them are concentrated on higher grades, around 8. But law even have a lower average grade in comparison to economics. We have probably very good students in law, even students with higher grades in economics. We have students scoring 9.7, 9, 9.5, 80 something. But at the same time, unfortunately, we have students law that have lower grades in comparison even to business administration with the lowest average grade, right? We have law students scoring 3.7, 4, 4.5, and so on, right? So if I was the dean of this course, I probably gonna have a very strong headache to work with law, right? How I can make sure that higher performer students can get interest and how I can get back traction students with lower performance and try to bring law something probably more homogeneous as economics. And for business administration, of course, I have a very large variation. I could try to make the group more homogeneous, but anyhow, probably it's easier to move the whole group upwards for business administration than law, right? Again, I guess I'm deviating here a little bit, but my point is the whole point about having this data, having this, let's call it sophisticated data analysis tool, it's about that. It's about understanding your business. It's about having threats on that. It's the main point of all of these, right? So to wrap up, I have again 2 additional exercise. One exercise that if you guys want, you can do it like right now. I have another data set for a swimming team with only their heights. So the idea is to create a histogram, calculate the quartile, and present the box plot, right? And here says, oh, let's define what you consider, for instance, a very low, a very short, not low, but short, right? Short, very short, a medium swimmer in terms of height, a very high, and a high and a very high swimmer, right? We could define, and those heights are in centimeters. So I could say, for instance, between 145 and 155, it's very short. Between 155, 165, it's short. Between 165 and 75, it's medium. Between 75 and 185, it's high. Between 185 and 195, it's very high. It's arbitrary. You as business expert, if I was swimming coach, I probably had this number on the back of my head. But yeah, let's work with that. So let's start with the histogram, right? Go back to blocks. Right, so let me throw all that away. Now I'm using the new data set. Oh yeah, and let me throw a table view. Here we have a table view. We have like 30 something swimmers with their heights in centimeters, as I said. And let's have a histogram for it, right? A histogram, as we saw, it is here. I have to select a specific column, right? The name of the column is this, height underline centimeters, right? Let me select the column. Right, and I can throw the bins as we define it as a list of numbers. I need to throw a couple more numbers on the gear, and that's it. Let's try between 145, 155, 165, 175, 185. Let's throw another item here, which should be 195. Okay, let's see that in Python. Same idea, right? We read a different data set now here. I'm still calling it data. Asked a histogram, right? Informing the column height within order from data. Define the bins, right? So between 45 and 55, it's very low. We have 5 guys very short. Between 135, 165, we have other 5 short guys. Between 165, 175, we have 6 guys considering medium height. Then we have quite a concentration with high or tall swimmers between 175 and 185. We have 14 of them. And we have another 6 very tall guys between 185 and 195, right? That's our histogram. And the other 2 question was, let's calculate the quartile and present the box plot, right? Back to Blockly. Let me throw that away, quite simple. The quartiles, I could come back again with the table view, through the quartile block from statistics menu, connect this, and that's it, right? So the shortest guy that I have on the team, it's 145. The tallest guy that I have on the team is 189. If you are below 163, when the 25% shorter of the team, to be in the tallest half, we have to be above 175. And in order to be in the 25% that are taller for my team, you should be above 179, 180 more or less, right? That's the distribution. And if you want to see that visually as a box plot, we can remove this and replace it with a box plot, right? Again, I can keep switching between blocks and code. yeah, I was trying to have both graphs in the same screen, right? We definitely see a concentration of higher or taller swimmers, right? So we see that on histogram, again, skewed to the right, and within the box plot, we see the very same symptom, right? We see a narrow upper part of the box, right? And that you see a concentration. So as swimmer coach, it seems that my team, it's at a high on average or as a group in a very good place in terms of height of swimmers. Of course, it depends on the strategy of the coach. If again, assuming that having taller swimmers, it's better than having shorter ones. In case the coach want to push the whole team even further, probably he could exchange or concentrate additional swimmers on the higher end, and probably, I don't know, dismiss a couple of shorter swimmers. He could redistribute some of these, right? But on majority, the coach or the team seems to be in a good place. Again, I'm not really familiar with swimming biology or strategy, but assume that taller guys are better than shorter guys for swimming. That seems the case. Guys, Molly, I guess you're right on time. I hope I had a good pacing here. Hope you guys enjoyed. Again, I can leave my contact information if you want to try again one of the exercise. If you want to try the challenge, get your own data set and play around with this stuff, feel free to reach me any time. Let me again leave my contact info.
Thanks so much. This was awesome. I'm going to be playing around more with Blockly and hopefully
Python.
Yeah, Python and all that. Yeah, thanks.
Yeah, thank you.
Thank you, Sergio. Thank you, guys.
Yeah.
Yeah.
Bye-bye.
Bye.